Hello everyone. Today we are going to discuss about our project on spam detection. Our team comprises of Arnab, me, Saurabh and Shubham are here to present a project on developing a spam filter and spam detection. Spam. This term is often used to describe unwanted emails but is also referred to unwanted messages sent through social media, text mining or other form of online communications. Spam messages are often sent to a large number of people indiscriminately with the goal of reaching as many people as possible in the hopes of tricking them into clicking on a link or providing sensitive information. The frequency and volume of spam messages are made in a major nuisance for many people and organizations and has led to developing of various anti-spam technologies and practices to combine it. Now we are facing this problem. We are going to discuss, develop a model which will help to improve this problem and find the solution. For this, we are going to take a data set and we have to do text pre-processing. The goal of text pre-processing is to clean and normalize and transform the raw text data into a format that can be easily analyzed and used to build a machine learning model. Our steps include converting the text into lower cases, removing stopwords, removing punctuation and special symbols, removing white spaces and streaming. By following these steps, preparation pre-processing steps, we are ensure that the text data is a clean, consistent format which will improve the performance of the machine learning model we are building. Our next step is to see what type of words are frequently used in spam detection and ham. By the word cloud, now we are gonna see in spams: call, free, prices, mobile, cash, phone, text, week are most common words are used in spam, and in ham we can see that go, come, back home, these are words are used. Now for the next slide, Shubham will be explained.
Thank you, Arnab. After data exploration, our next step is to do vectorization. Vectorization is the process of converting text data into numerical vectors that can be used as input to machine learning algorithms. This is necessary because most machine learning algorithms require numerical input and text data is inherently unstructured and difficult to use in its raw form. For vectorization, we use three approaches. First is TF vectorization, second is TF-IDF vectorization, and third is Doc2Vec vectorization. Uh, Coming to the first TF vectorizer, TF vectorizer creates a vocabulary extracting the unique words from the documents and keeps the vector with the term frequency of the particular word in the corresponding document. Simply, term frequency refers to number of occurrences of a particular word in a document. The first step in TF vectorizer was initializing the count vectorizer. After initializing, we fitted the count vectorizer to create a documentum matrix. After that, we converted the documentum matrix into a data frame. Coming to the second approach, it was TF-IDF vectorizer. TF-IDF stands for term frequency inverse document frequency. The TF of a word measures how frequently a word appears in a document, while the IDF measures how rare a word is across all documents in the corpus. The product of these two values gives us weight that indicates how important a word is to a particular document in the corpus. This weight is used in information retrieval and text mining to rank the significance of words in a document compared to an entire corpus. Again, the steps in the TF-IDF vectorizer is same as TF vectorizer. First step was initializing the TF-IDF vectorizer. Second was fitting the vectorizer to create a documentum matrix, and third was converting the matrix to a data frame. Coming to the third approach, it was Doc2Vec vectorization. Doc2Vec creates a vector representation of a document that captures its semantic meaning and context. This representation is generated by training a neural network on a large corpus of text using a supervised or unsupervised learning approach. The result embeddings can then be used as input for various NLP tasks such as sentiment analysis, text classification, and information retrieval. The first step was initializing the doc2vec vectorizer. Second, after initializing, we extracted the embeddings of every word from Doc2Vec vectorizer and created a document term matrix from that. After creating the matrix, we converted the matrix to a data frame. Now coming to dimension reduction and visualization. On all these three approaches, we did dimension reduction using principal component analysis. Coming on to dimension reduction on TF factorized data using PCA with 95 variance, we we plotted the scatter plot on the first and second PCA component of the data frame. As you can see, it was not able to capture the variance of ham and spam properly. Dimension coming to TF-IDF, PCA on TF-IDF vectors. It is the same as the previous one, not able to capture the variance properly. And dimension reduction on Doc2Vec vectorized data. It is also not able to capture the variance of ham and spam labels properly. Now Saurabh will explain the model fitting and performance of the models.
Thank you, Shubham. We have fitted a different kind of classification machine learning models in which we have used a logistic regression, which is the basic model for classification. Then we have used different tree models such as decision tree and using ensembling methods such as random forest, Adaboost, and bagging algorithm, as well as we have used SVM to classify the spam and ham methods. So during this model fitting, we have performed on various type of data frames such as TF, TIDF, and Doc2Vec matrix. Our aim was to classify spam mails. This data represents the logistic regression on TF data. Here we got precision as 0.97, recall as 0.75, and F1 score as 0.85. So this was and we tuned the model using hyperparameter tuning grid search, which gave us the best fitted results. After that, we have fitted Adaboost on TF data frame, which gave us precision of 94.94, recall of 0.84, and F1 score of 0.87. Then we have used bagging classifier on TF data, which gave us precision of 95, recall of 70.72, and F1 score of 0.81. We have also fitted a SVC model on TF data, which gave us a good precision of 1, recall of 0.6, and F1 score of 0.79. All the models were tuned by using hyperparameter tuning of grid search CV. Then we have used a TF-IDF data frame to classify spam and ham. We got using logistic regression of precision of 9.97, recall of 0.69, and F1 score of 0.81. Then the best classifier for this on TF-IDF was second best was Adaboost classifier, which gave us precision of 0.94, recall of 0.74, and F1 of 0.183. Also, SVC performed well on TF-IDF data, which gave us precision of 94, recall of 0.74, and F1 score of 0.82. After that, we use bagging classifier on TF-IDF, precision, where we got precision of 84, recall of 0.70, and F1 score of 0.78. We also we changed the matrix through Doc2Vec data, and again we use different machine learning models. We got Adaboost classifier as one of the best on Doc2Vec model, where we got precision of 0.84 on test data, recall of 0.86, and F1 score of 0.87, which was good. And after using bagging classifier on the Doc2Vec data, we got precision of 0.94, recall of 0.67, F1 score of 0.78. In the conclusion, using different machine learning models of text classification, spam messages can provide a robust approach to identify and filtering unwanted messages. Each has a strength and weaknesses. By combining them, we can leverage their complementary capabilities to achieve improved accuracy and performance. This can help us to overcome the limitations of any individual model and making it less likely to miss or misclassify spam messages. Additionally, evaluating the performance of different models and selecting the best suited one for the task at hand can further optimize the text classification process. The model which gave us the best results was spam classification on using Adaboost classifier on TF vectorizer data. Thank you so much. That's it.